third grade Cougars. Okay, so now we're going to start talking about current electricity. Last week we talked about static electricity, stationary electricity, electricity that doesn't move or flow. And now we're going to start talking about current electricity. So first of all, this week I want you to go to BrainPop and I want you to watch the videos on electricity and electric circuits. The next thing I want you to do is I want you to go to ReadWorks and I want you to read the articles on mountains and power. It's one article. And then we're also going to do on FET circuit construction. Okay? So let's get started with electricity. Okay, so before we move on with electricity, I just want to do a little review once again about static electricity and magnets. So when we talked about matter, solid, liquid, gas, matter is made out of atoms, and atoms are made out of three things. They're made out of protons, neutrons, and electrons. Protons have a positive charge. Neutrons have no charge at all, and electrons have a negative charge. Now, when we were talking about magnets, magnets have a north and a south end. And if I want this magnet to attract to this magnet, this end is a south end, and the rule is opposites attract. So if I want this bar magnet to attract to this one, this must be the north end, and this must be the south end. And then they would attract. However, if I want to have this magnet repel, I need to have the same pole. I need to have south and north. And then those two magnets would repel. Now, instead of having north and south, let's think about plus and minus. So instead of having north, I'm going to put plus. Instead of having south, I'm going to put negative. So if I have a magnet and I want it to repel, and this is a negative charge, what charge should I have here? I should have a negative charge. I should have a negative charge and a positive charge over here. So if I have two pieces of matter and there's two negative charges near each other, those two pieces of matter will repel, okay? Electrons will repel. All right, so keep that in mind as we start talking about electricity, current electricity, all right? Okay, so boys and girls, I have a picture of a battery on the board here, and I want you to notice something. I have a battery here in my hands, and I want to see if you can notice something about the battery. Do you see on this battery, here is a plus sign, and here is a negative sign. So this battery has a positive end and a negative end. And that's really important to notice. All batteries have a negative end and a positive end. And remember, matter is made up of positively charged particles and negatively charged particles. Electrons and protons, and neutrons which don't have any charge. Inside this battery, there's a little chemical reaction. There's some chemicals in here, and when those chemicals react, they create extra electrons. The process creates these extra electrons. Now, the electrons are inside the battery, and we want to get them out. So what I'm going to do is I'm going to take a wire, and I'm going to take a wire from the negative end of the D cell, and I'm going to take that wire and I'm going to put it to the positive end of the battery. I'm sorry I call it a D cell. It's just a habit of mine. One battery alone is actually called a cell. two batteries together is actually, or two cells together is actually a battery. But doesn't matter. If I take this wire and I go from the negative end of the battery to the positive end of the battery, now I have created a circuit, a place where those electrons can flow. So the electrons, remember, electrons have a negative charge, and they are in the negative end of the battery. They want to get away from that negative end of the battery. They don't like to be with all that negative energy. So what do? They are repelled out of the negative end of the battery. So the electrons have a negative charge. They are repelled out of the wire, and they travel through the wire. And as they get close to this end, they are getting to the positive end. And now they want to go to the positive end. They are attracted to the positive end of the battery. So here we go. They come here and they go, hooray! I'm attracted to the positive end of the battery. So they are now attracted to the positive. Here, they're the same charge, two negative charges, and they repel. Here, they're opposite charges, and they attract. That whole idea of attracting and repelling, what we learned about with the magnets, what we learned about with static electricity, it happens with current electricity too. Okay, I'm back to my plain battery again. Has a negative end and a positive end. And I want to talk a little bit about that circuit, okay? So if I have static electricity, what happens is that it's just a buildup of the negative electrons, but there's no path for the electrons to follow in order to have a current, to have them flowing. So static electricity is just a buildup of charge. Current electricity is a path that the electrons can take to move and to make things happen. Now, when I had just the wire going from one end of the battery to the other, that is called a short circuit. Short circuit. And a short circuit is not a good thing. You don't want to have a short circuit. If you do this, boys and girls, and please don't do this at home, this wire will get really hot because the electrons are repelled out of the negative end of the battery. They come out and they say, hooray, I'm going to get away from the negative end of the battery. And then they are attracted to the positive end of the battery and they say, hooray, I'm attracted. And what they are doing is just racing through that wire. They are running as fast as they can. They are rubbing. As they run through the wire gets hotter and hotter and hotter because of friction. So if you do something like this, the wire will get very hot and it will burn your hands. It won't hurt you very badly, but because you'll let go, but it will burn your hands. What you want to do is you want to give that electricity some work to do. And now I'm going to show you how you can do that. Okay, I'm back with my battery, which is the source of my energy, right? A bunch of electricity is stored inside that battery. Now, I want that electricity to do some work. I don't want to have just a short circuit where the wire gets hot. So what I'm going to do is I'm going to have a wire, and I'm going to put a light bulb, or maybe I'll do a motor first. I'm going to put a motor here with a little flag. Okay, so now this is the key thing. Electrons leave the negative end of the battery because they are repelled out, right? The electrons say, I want to get away. They are repelled out of the negative end of the battery. They travel through the wire. But this time, they have to do some work. They can't just run as fast as they can. They have to make the motor spin. They make the motor spin, and as a result, they don't have as much energy just to race around. Then they are attracted back to the positive end of the battery, and that completes the circuit. So this is the beginning of the circuit. It goes through the battery, the motor, and goes back to the battery. That is one complete circuit. Now, this is a closed circuit. There's no opening in it. When you have a closed circuit, the motor works. When I take the wire off of the battery, now it is an open circuit and the motor will no longer work. It's like you've turned off the motor. So this is an open circuit. There's an opening. There's no closing of the circuit. When you touch the wire back, it's a closed circuit and the motor will work. I love electricity. It's very interesting. Okay, so boys and girls, I'm going to show you a couple of things using this electronic snap circuit kit. And you don't have to, if you have one of these, great. If you don't have one, it's okay. I want to just show you a simple circuit using a kit like this. Okay, so I got all those materials and I just wanted to make a motor run. So I have 3 batteries and each one of them has a positive and negative charge end. And I used this to make a circuit. Now, one of the things that's really important that you notice that each one of these little snaps, that's where it's metal. And there's metal that connects these snaps to each other. Metal is a conductor. It passes the electrons on. So right now, I have an open circuit, right? I've got the motor. It snaps together with the batteries. That snaps together. Oh, look at this. This is an open circuit. Now, when I close the circuit, now my little motor is spinning. You can hear it. It goes so fast you can't really see it. Do you see it? So, when it's like this, it's an open circuit and no electricity flows. When I close the circuit, now it's a closed circuit and the electricity flows. Okay, we are back at the PHET website, phet.colorado.edu. We're going to go to simulations and we're going to go down to by grade level. We're going to click on elementary school. And then we're going to go down to Circuit Construction Kit DC. And DC means direct current. Click on that. And I'm not going to download it. You can if you want. I'm just going to play. Okay, now I'm going to do the intro first. So let's take a look at this. Here's the wire, here's the battery, a light bulb, a switch. We're not going to talk about the resistors right now. There's fuse, paper clips, coin, all these different things that we can test, okay? So what we want to do is we want to make a circuit. So I'm going to start with my source, and my source is the battery. Click, okay? So I'm going to take my battery here, and you can see that it's got all these, it's full of negative charges because electrons have a negative charge. Now I'm going to click on a wire, and I'm going to take my wire over here, and I can stretch my wire out. I'm going to get another wire. I'm going to put it here. I'm going to connect it. And then I'm going to bend it down because I want to make a circuit. And I'm going to get another wire and connect it here. And I am going to put a light bulb on in my circuit. And I'm going to get another wire. I'm going to connect it here. And I'm going to get another wire here and connect it to my battery. Aha! So here you can actually see the electrons flowing. They leave the negative end of the D cell or of the battery because they are repelled out of the battery. The same charges repel, so it is repelling out. It's traveling through the wire because the wire is made out of metal. Metal is a conductor. It passes the electricity on. It goes through the light bulb, and the friction creates light and heat. It goes back through the wire and is attracted to the positive end of the battery. Okay, now that's a closed cell, a closed circuit. I'm going to take this. Oh, I think how do I get this to break? I'm going to click that open. So now it's an open circuit, right? And when there's an open circuit, no electricity flows. If I close it, it works. Click it, it stops. So boys and girls, I want you to go to phet.colorado.edu, and I want you to make all kinds of different circuits. In your notebook, I would like you to draw a picture of at least 2 circuits that you built on the PhET website and show the direction that the electrons are moving and write down why the light is working or why the light is not working. Okay.